Okay, so average rate of change is the change in a value of a quantity divided by the elapsed time. And that doesn't make any sense. But that's okay, because there's a formula for it. So it's a little bit easier than you might think. Basically what the average rate of change is the slope without calling it the slope, because you cannot call it the slope because it is not quite a slope. And that's really the only reason it's not called slope. So basically what it is the f of b minus f of a over b minus a, or if you're not comfortable with using b or a terms, you can just say f of x2 minus f of x1 over x2 minus x1. And basically that's all that's saying is that there's one term, which we can say is 6, and then there's, like, I don't know, 5. This would be your x1, and this would be your x2. And to make it even more simple, those are talking about points in a graph. So it's a point here, and then a point here. I'm just saying that this would be x3, y looks like 2, and this would be like -5, 2. And you only want the x values. So in this case, this would be your x1, so this would be f of -5 minus f of 3 over -5 minus 3. And I mean, that's it. Sometimes you're not really given everything you need to know, but we'll start simple. So here's our first problem. To solve for the rate of change, you will need the equation thing, which gives you the graph, or not really the graph, but, you know, the parabola or the line or whatever you need. I don't know terms. And the interval thing, which is the two numbers you need. And what that will give you is on the graph, f of x equals 2x will end up giving you a parabola, and you are trying to find the interval of 3, 6. And so what you do is you plug in the intervals into your formula. And so f of 3 equals 2 times 3 squared, as it says here, which gives you 18, and then f of 6 equals 72. And basically, you can go all the way down here, and then you plug in your values. F of 6 minus f of 3 over 6 minus 3, or 72 minus 18 over 6 over 3, which gives you 54 over 3, which 54 is divisible by 3, so you can simplify it to 18. And the average rate of change between the interval 3, 6 would be 18. But if your teacher does not like you, which is very likely, you might get something that ends up looking like this, without a graph. Basically, left to your own devices, if you're lucky, you might get a calculator. So what you get is the formula kx equals -x squared plus 6x, and all kx is really doing is trying to confuse you and make you think, oh, what do they mean kx? That's not an f. I can't do this problem. But you're wrong. It's just f disguised as a k. So it's basically the same thing, and then that gives you -x squared plus 6x, and then you get x equals 4, this is the nice one, and then x equals 4 plus h, and h shouldn't really be there, but it is. So, really simple. You just do the same thing, you go k, or do it in Sharpie instead. You go k, 4 equals -4 squared plus 6x, I mean 6, 4, which will give you, oh, damn. And then this will give you 8. And you go further down and you plug in k 4 minus h equals negative 4 minus h squared plus 6 times 4 minus h. And you end up with negative h squared minus 2h plus 8. So these are the two values you will use in your average rate of change formula. So you go f of 4 minus f of 4 minus h over 4 minus h minus 4. I mean, this is longhand, but you would, end up with negative h squared minus 2h plus 8 minus, sorry, these should be rearranged. So, but yeah, anyway, you get the point. You end up with this minus 8 over 4 minus h minus 4. But wait, there's more. That rhymed. That simplifies down even further. And you'll end up with h minus h minus 2 over 4 minus h minus 4. These two cancel each other out, and then these two cancel each other out, and you're left with negative h minus 2, which equals h minus 2. Schnazzy. And so those are the basics for the average rate of change. I mean,